Addition, subtraction, and multiplication. I'm sure there's multiple different ways people have learned to do this by hand, or even on their fingers, with their hands. But when I was a child, before all of this core math stuff, we did it very simply. Let's say we have 18 and 47. Well, if we add those, we'll put a little plus. You start in the right column. 8 and 7. Well, I do 8 and 8 is 16, so it's 15. So we write a 5 here. What do we do with the 1? We call that a carry. We carry the 1. Now we have 4 plus 1 plus 1. So that's 6. So 47 plus 18 is 65. And, do that enough and it's going to be really fast. But why does that work? Why does that work? Positional notation. 18 plus 47 is 1 times 10 to the 1 plus 8 times 10 to the 0 plus 4 times 10 to the 1 plus 7 times 10 to the 0. This is 18, this is 47, and then we add. And so what did I do? Let's go through the steps again. The zeros place, 8 and 7. So, again, it's 15. So we get 15 times 10 to the 0. But this is base 10. We don't want this to be bigger than 9. We want 0 through 9. Well, what is 15? 15 is 10 plus 5. See, now imagine it as positional notation. So we've got 10 plus 5. So it's 10 plus 5 times 10 to the 0, which is 10 times 10 to the 0 plus 5 times 10 to the 0. What's 10 times 10 to the 0? It's 1 times 10 to the 1, because we just pulled out our base. So now we've got 1 times 10 to the 1. So instead of writing 8 and 7 here, we can write that we have 5 times 10 to the 0 and 1 times 10 to the 1. But that goes over here, doesn't it? Plus 1 times 10 to the 1. In fact, I'll write it above. There's our carry. Now, this plus this is 6 times 10 to the 1. 65. That's addition. That's carrying. Nice and simple. Remember, if you have 137 plus 12, that's 0, 1, 2. If we're doing 0.9 and 0.74, it's 0.90. Just add zeros, and you get your columns all nice and neat. So addition is nice and easy. How about subtraction? 34 minus 9. How do we do that? Same way. 4 minus 9, we can't do that. Well, we could do 34 minus 9. We're already doing 34 minus 9. The idea is we can't do that in our head. You memorize the lower numbers, but you don't memorize every single number that ever exists. There's too many. Well, what is 3? 3 is 2 plus 1. So what if I say this is a 2 instead, and I put a 1 here? Well, that's called a borrow. I borrowed 1 from there. Now I've got 14 minus 9, so that's 5. And then we have a 2 minus 0, because there's a 0 there. 2 minus 0 is 2, so that's 25. So what just happened? Let's go over it again. 34 minus 9. 34 minus 9. Well, 3 times 10 to the 1 plus 4 times 10 to the 0 minus, this will be a polynomial, 9 times 10 to the 0. There's only one term in our polynomial, but if there were more, it would just be minus, 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 subtracting each digit. So I've got minus. Let's write it over here. So how did I do that borrow? Because we want to do 4 minus 9, but we can't. 3 times 10 to the 1 equals 2 plus 1 times 10 to the 1 equals 2 times 10 to the 1 plus 1 times 10 to the 1. So I just took this 3, and we got 2 times 10 to the 1 plus 1 times 10 to the 1. So I just broke that apart. What is 1 times 10 to the 1? It's 10 times 10 to the 0. 1 times 10 to the 1 is 10 times 10 to the 0, which is invalid. Again, we don't want 10 in base 10. It should be digits 0 through 9. But we're doing this temporarily in the algebra. So I've got 10 times 10 to the 0 over here, plus 10 times 10 to the 0, which gets rid of that 1. So now I've got a 10 and a 4 and a 9. 10 times 10 to the 0 plus 4 times 10 to the 0 is 14 times 10 to the 0. We just combined them, and now 14 minus 9, well, there you go. There's your 5. So you end up with 5 times 10 to the 0. And then we were done. I don't really need to go through a whole bunch of digits. You get the idea. When you carry in addition, you get that extra digit that you promote 1 order of magnitude and combine with the next digit. When you borrow, you take the next digit and you split off one order of magnitude and pull it back and convert it, you demode it to a lower order of magnitude so you can combine it with this. You move some value from one column to the other, and you just do that visually. What about negative numbers? If you have 3 plus negative 4, that's just 3 minus 4. If you have 3 minus negative 4, that's 3 plus 4. If you have negative 2 plus 7, that's 7 minus 2. Just reorder, and you get addition and subtraction. So that's how you do that by hand. You just reorder. Now for the fun one, multiplication. So we write polynomials. That's what positional notation is. Digit times base to the 0, digit times base to the negative 1, all added. If you have two polynomials, a plus b plus c times d plus e plus f, all you do is you multiply them term by term. So you've got a plus b plus c times d plus a plus b plus c times e plus a plus b plus c times f. So we just brought this over, this over, this over. And then you do it the same in each of these. So you've got AD plus BD plus CD plus AE plus BE plus CE and so forth. You just take one of the polynomials and go term by term into the other. We do that with digits when we multiply. The process of multiplication, if you have 214 times, let's do x, times 31. Well, we do 4 times 1 is 4, 1 times 1 is 1, 2 times 1 is 2. Then we add a 0, and we do the second digit. 3 times 4 is 12, carry the 1. 3 times 1 is 3, add 1 is 4. 3 times 2 is 6. And then, to not get confusing, delete your row, just erase it, if you have more digits. And your final step is addition. So now, you in fact can just ignore all this, because this is done, and we just add these two. 4 plus 0 is 4, 1 plus 2 is 3, 4 plus 2 is 6, 0 plus 6 is 6. 214 times 31 is 6,634. What in the world was all that sorcery? Well, let's look. 214 times 31 equals 6,634. What in the world did I just do? So we've got 2 times 10 to the 2 plus 1 times 10 to the 1 plus 4 times 10 to the 0 times 3 times 10 to the 1 plus 1 times 10 to the 0. Here's our polynomials, our numbers written out. So if I do that, over here we get 2 times 10 to the 2 plus 1 times 10 to the 1 plus 4 times 10 to the 0 times 3 times 10 to the 1. That's our first term. Then we do it again with our second term. So plus 2 times 10 to the 2 plus 1 times 10 to the 1 plus 4 times 10 to the 0 times our second digit, 1 times 10 to the 0. So it should be obvious how we can go through and just take this 3 and multiply it through, and the 1 and multiply it through. Let me go ahead and write parentheses to indicate that. So that was each line I did. I did 3 multiplied by these digits, right? And then I did 1 multiplied by those digits. Actually, I did it the other way. I did 1 and then 3. But I offset the 3 line by a 0. Wasn't that odd? We've got 10 to the 1 here, and this is 10 to the 0. So basically, this line is times 10. What is times 10? Add a 0. Move the decimal point to the right. So I did the same operation on both lines, but this one, at the bottom, I just added a 0, and then it was crooked. And you gotta, that's one of the things you gotta be careful about when doing that multiplication method. Remember, once you add that 0, it's crooked. And you say, well, why not just don't add the 0 yet? Well, because then, when you go to add, you have it crooked when you're trying to add. So what you might do is not add the 0. You might just do it line by line and then rewrite it and add the zeros then to add. Whatever. But it's 2019. I guess you're not going to be doing this by hand. If it's too big to be doing in your brain, then you're going to be using your phone, I guess. But the point is, this is where that 0 came from, this 10 to the 1. Algebraically, we separate the digit from the magnitude. It's magical, it's fun, it's wild. And I'm sure most of you are not watching this video at this point because you think it's useless. A specific fact can be useless. I will admit that. A specific fact could be useless throughout your whole life. But the process of learning that fact is still useful. I've said this multiple times. The process of learning, figuring all this stuff out, it trains your brain, you understand better. It's useful to learn even if the thing you learn is not useful. I hope I'm getting that point across and not boring you to death. So next video, I'm going to do division because I only have so much room on my board, and it's not quite as pretty. Division is messy and it's ugh, but it's something we have to live with. So while we wait to swallow that bitter pill, I'll be seeing you.